A NoSQL, not only SQL, database is a type of database management system that provides a flexible and scalable approach to storing and retrieving data. Unlike traditional relational databases, which are based on tables, rows, and columns, NoSQL databases use various data models to organize and represent data, such as key-value pairs, document-oriented, columnar, or graph-based structures. Here are some key characteristics and features of NoSQL databases. Schemaless. NoSQL databases are typically schemaless, meaning that they do not require a predefined schema or fixed structure for data. This allows for more flexibility in storing different types of data without the need for upfront schema design. Scalability and high performance. NoSQL databases are designed to handle large amounts of data and high traffic loads. They are horizontally scalable, meaning they can distribute data across multiple servers, enabling high availability and performance. Flexible data models. NoSQL databases support various data models, including key-value, document-oriented, columnar, and graph-based structures. This flexibility allows developers to choose the most appropriate data model for their specific use case, optimizing performance and storage efficiency. Distributed architecture. NoSQL databases are often designed with a distributed architecture, allowing them to scale horizontally across multiple servers or nodes. This distributed nature enables data replication, fault tolerance, and load balancing. High availability. NoSQL databases typically provide mechanisms for data replication and automatic failover, ensuring high availability and fault tolerance. This means that even if some nodes in the database cluster fail, the system can continue operating without significant downtime. Designed for big data, NoSQL databases are well suited for handling large volumes of data, especially in scenarios involving big data analytics, real-time streaming, and high-speed data ingestion. Use cases. NoSQL databases are commonly used in scenarios where high scalability, flexibility, and performance are critical, such as web applications, content management systems, e-commerce platforms, real-time analytics, IoT data processing, and social media platforms. Certainly. Here are some additional details about NoSQL databases. 1. Data models. Key-value stores. This model stores data as a collection of key-value pairs. It offers fast access to data based on a unique key and is commonly used for caching, session management, and simple data storage. Document databases. These databases store data in flexible, semi-structured documents, example, JSON, XML. They allow nested and complex data structures and are suitable for content management systems, blogging platforms, and document-oriented use cases. Columnar databases, also known as column family databases, they store data in columns rather than rows. This model is efficient for analytical queries and data warehousing, where aggregations and analysis across large datasets are common. Graph databases. Graph databases are designed to represent and store graph-like structures, where data entities, nodes, are connected by relationships, edges. They excel in scenarios involving complex relationships and graph queries, such as social networks and recommendation engines. CAP theorem. NoSQL databases are often associated with the CAP theorem, which states that in a distributed system, it is impossible to simultaneously achieve consistency, availability, and partition tolerance. NoSQL databases typically prioritize availability and partition tolerance, sacrificing some degree of strong consistency. This means that in the event of network partitions or failures, NoSQL databases may allow for eventual consistency rather than immediate consistency. Polyglot persistence. NoSQL databases embrace the concept of polyglot persistence, which means using multiple storage technologies to handle different types of data within an application. For example, a NoSQL database might be used for storing user profiles and session data, while a traditional relational database might handle transactions and financial data. ACID versus base. While traditional relational databases adhere to ACID, atomicity, consistency, isolation, durability, properties, NoSQL databases often follow the base, basically available, soft state, eventually consistent, principle. Base provides looser consistency guarantees, allowing for high availability and scalability in distributed systems. NoSQL database examples. Some popular NoSQL databases include MongoDB, Document Database, Apache Cassandra, Columnar Database, Redis, Key Value Store, Neo4j, Graph Database, and Amazon DynamoDB, Managed NoSQL Database Service. 1. Interactions with programming languages. NoSQL databases usually provide libraries, drivers, or SDKs for various programming languages to interact with the database. These libraries offer APIs and abstractions to simplify data access and manipulation. It's important to note that while NoSQL databases offer flexibility and scalability, they may not be suitable for all use cases. Factors like data consistency requirements, complex transactional operations, and the need for ad hoc querying may still favor traditional relational databases. Ultimately, the choice of database technology depends on the specific needs and characteristics of your application.